Okay, now members are going to see how do we solve two simultaneous equations using a matrix method. We are going to see more methods, but here we are going to specifically be on a matrix method. So let us see how we go through that. So we are going to first make a note. If A is this and if A is this, it means that the adjoint of A, if you multiply the adjoint of A first times the matrix itself, you get the determinant of A in the leading diagonal, determinant of A, and zeros in the minor diagonal. Let us see an example. If A is this, I think start to determine the adjoint of A, we interchange, then we multiply the minor with the negative sign, a negative 1, which is this. You start when we get adjoint first times A, we get 4 negative 1 times this. When we multiply, we start to get 5, 0, 0, 5. But you note that the determinant of this A will be 8 minus 3, which is 5. I think you see it's coming to this idea. We'll try another example. If B is this, adjoint of B is this. Now, when we multiply adjoint first times the matrix B, you get negative 4, 0, 0, negative 4. And when we try to calculate the modulus, the determinant of this, I think you see you get negative 6 minus 2, which will be a negative 4. And we see it's in the leading diagonal or the major diagonal. So note that we are going to use it here when you are calculating this. We don't need to go through a lot if you don't have idea. Now, so they are giving us this and this. Now you see that we first rearrange. X is in terms of X, that is okay. Y in Y, it's okay. But this one is not its side. So we put this the other side. So now we rearrange. So we shall be having now 3x, now 4x, equaling 2. Now when I take this aside, it becomes 11. Now from there, what we do, we pick out the coefficients. So we pick out the coefficients. Shall be having now 3, 2, 4, 3. Then x, y, this order x, y, it will be equaling 2, 8, 11. Now, this matrix, we multiply the adjoint both sides. So, if I call this our matrix A, which is 3, 2, 4, 3, we get its adjoint. So, its adjoint of A will be, we said we interchange, but if we interchange, it's the same. 3, 3, then multiply here by negative 1 in the minor. So that's what we have. Now, if we multiply this adjoint, should be multiplied first, always to the left of this, to be multiplied to both sides. Like we see that it's always multiplied to the left. So when I get this adjoint, I multiply it here first. Then this one will be 3, 2, 4, 3, x, y. I also multiply the same adjoint this side, but first. So it's always on the left of those matrices, 8, 11. Now also note that the determinant of A is going to be, that will be 3, that will be 9, minus 8, which will be 1. We said here, don't waste time. If you get the adjoint times the matrix itself, the adjoint times this, we say you get the determinant of that matrix, then here 0, 0. And you've seen there that the determinant is 1. So this is going to be 1, 0, 0, 1. Then into x, y equaling 2. Can you multiply here? 3 times this, 3 times this, that will be 3 times 8, that will be 24. then negative 2 times this, plus negative 22. Then negative 4 times 8, that is negative 32. Then plus 3 times 11, that is 33. So here, you see that here we can easily say this times this, and then you can also multiply with ease. This times this is that this is the 2 by 2, and this is the 2 by 1. You can just multiply. This times this will be 1 plus 0, which will be x. Then this will be 0 plus this, which will be y, equaling 2. Now when you simplify, we have 2, and here we have a 1. So therefore our x is 2, and our y is 1. And there you have solved it with ease. When I come now to this, I have P and Q. Are they arranged properly? Constants are one side, that is okay. I'm seeing the P and the Q. So I first rearrange also. So rearrange. I have 2P minus Q equaling to negative 4. Then if this is P that is starting in equation 1, you also bring P first. So this P, I bring it here. 4P, then this Q with its sign, plus 3Q will be now 7. Now I take out the coefficients. This will be 2, 4, then this is negative with its sign, so it's negative 1, the coefficient. This is negative 1, then 3. Then in the order PQ will be equal to 2. Now this one's negative 4 with its sign, like that. So here our matrix A is this. So you multiply the aggregate first and then decide first. So anyway, if you can do it with ease, you don't need to do this. Okay, 2, negative 1, 4, 3. So that now my aggregate of A will be now 3, 2, negative 4, 1. Then let us get the determinant of A. Determinant of A will be this, which will be 6. Then minus, that will be, then minus, this will be 6. Then minus, this time this, negative 4. And that will see, it's going to give us 10. So after getting a 10, you multiply the aggregate on the left and here also on the left. So my aggregate, which is 3, 1, negative 4, 2. Now you are multiplying it here and here. Into PQ equaling 2. Now still the adjoint, which is 3, 1, negative 4, 2, into now negative 4, 7. Then from there, we say don't waste time here. It's going to be the determinant in the leading, then this one's going to be 0, 0. So this one is going to be now 10, 0, 0, 10. P, Q. Then we can multiply the sign. 3 times this will be negative 12, then plus 1 times 7, that is 7. Then negative 4 times negative 4, that is 16. Then plus 3 times, 2 times 7, that will be 14. So can you multiply here? 10 times this, that is 10p. 0 times this. So 10p plus 0, which is that. Then this time this is 0. Then this times this is 10q. Equaling to, this will be, when you simplify there, it's negative 5. Then this will be 30. So meaning that now our 10p is equal to negative 5, our 10q is equal to 30. Can we divide? So that our p becomes negative 5 over 10, and so our p will become negative half. Then what about our q? Our q will be 3. So we have solved those from the two impedance equations. So that's it, members. I wish you well.